KRRL-NTS Net nightly at 6:30 p.m. W5FC.
Does anyone need to use a repeater before we begin the 9 p.m. Skynet? This net is open to all amateurs interested in this topic, and we encourage your participation. Comments and suggestions for this net. Stations with priority or emergency traffic may enter the net at any time by using the pro sign, break, break, and your call sign. Is there any emergency traffic or priority traffic? This is a directed net. Please do not transmit without direction from net control. That would be me. And stations are reminded to ID at the end of your transmissions. This weekly net operates on 146.88 megahertz with the L-Tower 110.9. And check-ins via echoing are also possible using the W5FC-star station ID or echolink node 37247. Tonight's topics: astronomy charts, pictures of live audio video links are available online. Go to w5fc.org right now for that complete list. Remember to tell others about this popular net. All amateur operators are welcome. think I heard the tail end of your check-in. If so, would you please come back?
Yeah, JJ on Echolink said I lost the double. Yeah, KF5, JHA, Chaz and Mesquite.
Okay, KF5JHA Chaz. All right, additional check-ins, please.
Kilo 5, Zero, Mike, Bravo, Charlie, Shane, Blue Springs.
Kilo Foxtrot 5, Papa Delta Sierra, Billy, and Sherman.
India 5, Bravo, November, Papa, Luis in Fort Worth.
Okay, K5ANP, Alan, W0MBC, Shane, RF5PDS, Billy, and Luis, I missed your prefix.
Is Kilo India 5, Bravo, November, Papa.
Thank you. Kilo India 5, Bravo, November, Papa. Luis. All right, any more general check-ins? Please come down.
This is Whiskey, Bravo, number 4, Mike, Foxtrot, India, WB4, MFI, Ted, Dallas, low power.
Okay, we got WB4MFI 10. All right, let's go ahead and get started. We'll get more check-ins later. Okay, what do we have first? General announcements. Do we have any general announcements for this evening's net? These can be ham, astronomical, space, or of general interest to licensed hams.
November 5, Bravo, Bravo.
And 5BB, go ahead, Bill.
Well, I was hoping at the end, but I was on TechNet and heard the unfortunate news that our good local ham buddy, Dave, KD5IZF, over in Mesquite, passed away on Friday. And a small service is being planned. This is in 5BB. Sad news.
I'm so sorry. Thank you for the information. Okay, additional announcements. AMSET Radio Amateur Satellite Group has 2 nets available to Dallas residents. Tuesday evenings at 8 p.m. Central. You'll need Echolink installed and be registered. You can find the net under Groups and AMSET. Also, live audio link is available on their website, amsetnet.com. This net originates in Houston. Dallas AMSET Net East, Dallas-Fort Worth, Texas, is every Tuesday at 8 p.m. on this repeater, 146.88 megahertz, PL tone, 110.9 megahertz, Tuesdays. Tom, N5HYP, is net control. All are welcome to check in. First Tuesday of the month is the DARC Club night, so no AMSET East that night. Dallas AMSET Net Dallas-Fort Worth, Texas, is every Wednesday at 9 on the Arlington repeater, 147.14 megahertz, PL 110.9 megahertz, positive offset. Let's skip over the list of all the nets. You can find those on the website if you need to. All right, tonight's Afterglow info. In case you're new, every Saturday, every week we are assigned a movie to watch, and on Saturday night at 10:30 we discuss it. Generally it's a 1950s B movie, sci-fi, but not this time. We've got a modern color movie, and it's not sci-fi. And here is the synopsis. Captain Howard looked at the map yet again. He was the new master of the RMS Titanic II, a massive ship built to look and perhaps sink like the original. 100 years later, Howard has a whole to study. He had seen A Night to Remember, Titanic, and even that time travel episode with Michael Rennie as the captain. He observed all the mistakes, but to be sure, he'd covered all his bases. He also watched the Poseidon Adventure, its remake, Poseidon, and the sequel, Beyond the Poseidon Adventure, and he even knew Red Button's role line by line. The captain checked the weather. Giant iceberg located on the route and tsunami wake probable. Well, that's good enough for me, stated the captain. Let's weigh anchor and head to England. Sure, why not? Asylum Films brings us for a future tale from the past. Titanic 2, made in 2010, tonight at 10:30 p.m. You can keep up with all the DARC events, nets, and activities by going to the club website, w5fc.org. Okay, let's do additional check-ins.
Recheck. Zulu Mike Golf, Joe in Arlington. Check.
Okay, Joe, I missed your prefix.
Joe Golf 5, Zulu Mike Golf, Joe in Arlington.
Kilo Golf 5, Zulu Mike Golf. Joe, did you have something to bring us?
I'm sorry, I thought you were asking for additional check-ins.
I was. I'm sorry. I thought you had something to add. Okay, welcome to the net. Anybody else?
Kilo, check.
Bravo, Zulu, Whiskey, J, near Weatherford.
Okay, we've got Kilo Golf 5, Bravo, Zulu, Whiskey, J. All right. All right. Chaz, KF5JHA, do you want to give us the Texas Astronomical Society of Dallas events?
Thank you, Brenda. Yes, this is Chaz, KF5JHA. The next meeting of the Texas Astronomical Society of Dallas is on September 25th. That's going to be this coming Friday, 6 days from now, at 7:30 p.m. It'll be another virtual club meeting using Zoom. We won't have a speaker at that meeting, but instead we'll be having a swap meet. Now, the Texas Astronomical Society of Dallas usually has a swap meet once a year, but as far as I know, we've never done this virtually. It's going to be interesting how that happens. So swap meet is when members bring in to the meeting their unwanted, gently used, well, usually gently used equipment and sell it. Task Club members will receive an email link to the meeting, probably in the next few days. And hopefully TASK will resume face-to-face meetings and public observing sessions sometime after this shelter-in-place is over. Check their website for details at texasastro.org for details. And this is KF5JHA. Back to you, Brenda.
WB50ZL, are you still there? From KE5I6. Interesting, that's never happened before. This is KE5ICX. I'll just take it from here for a little bit until Miss Brenda's back. Next up is National Space Society Events and Activities. Bill, N5BB, would you like to give us an update on National Space Society of North Texas from KE5I6?
Yes, Tom. This is N5BB. I am the membership director of the National Space Society North Texas chapter. If anybody has any interest in the National Space Society, you can reach me at n5bb@arrl.net. That's November 5, Bravo Bravo at arrl.net. National Space Society has stopped all in-person meetings due to the COVID-19, but we're still doing monthly meetings via WebEx. Our last meeting, which was our September meeting, we meet on the second Sunday afternoon of every month. And so we just had our September meeting. And the topic of that meeting was concerning some Mars geology. It was an extremely interesting presentation by a researcher who now lives here locally, who was involved with JPL and some other NASA investigations. And the results of all these investigations are indicating that there's some features on Mars which seem to be created by lava going over water, areas with water. So the lava heated up the water, causing the water to spout up, kind of like a bubble or geyser thing, making a hole in the lava. So it makes these little small cones that are kind of like small volcanic cones. And they're seen in a few places on Earth, very few places. But they're in one particular of Mars, there's a whole bunch of them lined up. So this tells us a lot about the previous history of water on Mars. Anyway, that was our September meeting. Our October meeting, our speaker is going to be from NASA, Amy Ross, who is a scientist and engineer at NASA JSC in Houston. Amy is she's in the Crew and Thermal Systems Directorate. So she's involved with leading the team to building the spacesuit pressure garments for extra vehicle activity, etc. So they're directly working on what's going to be used by astronauts going to the moon and maybe to Mars. And she's right in the middle of that. She's in charge of a lot of it. Anyway, in the past she's worked on the shuttle spacesuit gloves and all kinds of other things. Anyway, the reason she's going to be talking to us specifically here this next month, by the way, the meeting in October will be on Sunday afternoon, October the 11th at 4 p.m. Again, this will be a WebEx virtual meeting, Sunday afternoon, October the 11th at 4 p.m. And she's going to be talking to us about some spacesuit material that's on the Perseverance rover. And so the idea is when it arrives on Mars, that material will be exposed to the Martian atmosphere and sunlight, etc. And they're going to be able to use a tool on the sensor tool on the rover to look at these pieces of spacesuit material. This is proposed spacesuit material, and compare them against some calibration targets and other things. So the neat thing about this is they'll be able to determine over a significant time frame how these spacesuit materials are surviving in the Martian atmosphere. So she's going to be talking about this with a presentation. If you'd like to visit our meeting, you can. We'll be glad to send you a credentials for checking in. If you'd like to do that, send me an email, n5bb@arrl.net. And that's all that's going on here locally with National Space Society right now, these monthly meetings online. This is N5BB. Thank you, Brenda or Tom, whoever's going to be net control from now on.
Sorry, I had a catastrophe. So I'm back, but who knows? I have a lot of those. All right, moving on to our feature presentation. Tonight we're going to talk about possible life on Mars. They did not discover life. They discovered phosphine, which could indicate some kind of life. So this is really pretty exciting. So, there's something funky going on in the clouds of Venus. Telescopes have detected an unusually high concentration of the molecule phosphine, a stinky, flammable chemical associated typically with feces, flatulence, and rotting microbial activity, and an atmospheric layer far above the planet's scorching surface. The finding is curious because here on Earth, phosphine is essentially always associated with living creatures, either as a byproduct of metabolic processes or of human technology, such as industrial fumigants and methamphetamine labs. Although toxic to many organisms, the molecule has been singled out as a potentially unambiguous signature of life because it's so difficult to make through ordinary geological or atmospheric action. Swathed in sulfuric acid clouds and possessing oppressive surface temperatures and pressures, and temperature is hot enough to melt lead. Venus is a hellish world, but the particular cloud layer where the phosphine is present happens to be relatively balmy, with ample sunlight and Earth-like atmospheric pressure and temperature. The results will have to be carefully vetted by the scientific community, yet they seem likely to spark renewed interest in exploring our sister planet next door. It's a really puzzling discovery because phosphine doesn't fit in our conception of what kinds of chemicals should be in Venus's atmosphere, says Michael Wong, an astrobiologist at the University of Washington. Planetary scientist Sanjay LeMay of the University of Washington, Madison agrees. The bottom line is we don't know what's going on, he says. Neither Wong or Sanjay were involved in the work. After the Sun and Moon, Venus is the brightest object visible to the naked eye in Earth's sky. For thousands of years, people told stories about the glittering jewel that appeared around sunrise and sunset. Venus's brilliance is what made it attractive to Jane Graves, a radio astronomer at Cardiff University in Wales. She typically focuses her attention on distant newborn planetary systems, but wanted to test her molecular identification abilities on worlds within our cosmic backyard. In 2017, Graves observed Venus with the James Clerk Maxwell telescope in Hawaii, searching for barcode-like patterns of lines in the planet's spectrum that would indicate the presence of different chemicals. While doing so, she noticed a line associated with phosphine. The data suggested the molecule was present at around 20 points per billion in the planet's atmosphere, a concentration between 1,000 and 1 million times greater than that in the Earth's atmosphere. I was stunned, Graves said. Phosphine is a relatively simple molecule containing 1 phosphorus atom and 3 hydrogen atoms. It's known to reek of garlic or rotting fish, though by the time it reaches concentrations where humans can smell it, it is likely to cause lung damage. In the pilot episode of the series Breaking Bad, the character Walter White prepares phosphine gas to knock out 2 assailants who are threatening him. Yet making the substance is not as easy as seen on TV. Phosphorus and hydrogen hate each other, says Clara Sousa Silva, a molecular astrophysicist at the Massachusetts Institute of Technology and co-author of a study reporting the phosphine findings. Hydrogen has much better stuff to do, and phosphorus would rather bond with oxygen. But if you throw enough energy at them, they can come together and be stable in some environments. The gas giants Jupiter and Saturn contain phosphine because they have hot interiors where it can be energetically favorable to produce the molecule. Venus's runaway greenhouse atmosphere, by contrast, is full of oxygen-containing chemicals such as carbon dioxide that would normally soak up phosphorus. For the molecule to be present at any level, let alone the amounts Graves was seeing, was a genuine head-scratcher. Meanwhile, Sousa Silva has built her career around studying phosphine. She goes by the handle at Dr. Phosphine on Twitter, predicting how it might appear in the atmosphere of a distant alien exoplanet. Thus, considering these exotic worlds light years away, super-Earths, the tropical planets, sewage planets, she says, and the whole time it was just here next door. The researchers and their colleagues made follow-up observations of Venus with a more powerful Atacama large millimeter submillimeter array in Chile last year, again detecting the atmospheric signature of phosphine. Then they tried to come up with every possible of the strange molecule's existence, including volcanic activity, lightning strikes, and even meteorites breaking up the planet's atmosphere. I think the best routes we could find fell short by a factor of about 10,000, Graves said. Of course, there might be additional pathways to making phosphine the team has not yet considered. But after exhausting their imaginations, seeking out abiotic explanations, the researchers felt forced to acknowledge one other possibility in their paper, which appeared today in Nature Astronomy. The molecule could be made by life on Venus, just as life is the main way it manifests on Earth. Astrobiologists have long been enamored with Mars, a dry, rocky planet with conditions not all that dissimilar to those on Earth. More recently, they have become moonstruck by icy, potentially habitable worlds in the outer solar system, such as Saturn's geysers, Ewing satellite Enceladus, and Jupiter's oceanic moon Europa. But despite its drawbacks, Venus has not been entirely neglected by scientists speculating about life's extraterrestrial abodes. From 50 to 60 kilometers above the Venusian surface, there is an atmospheric layer with pressure equal to that of sea level on Earth and temperatures between 0 and 50 degrees Celsius. If not for the sulfuric acid clouds, one might call this later hospitable. Even so, there are terrestrial organisms that will happily tolerate such extremely acidic conditions in hot springs or other environments. This relatively clement region is precisely the place where the phosphine has been found. Since the 1960s, astronomers have also noticed that Venus's clouds are not reflecting as much of the sun's ultraviolet light as they should be. An unknown something in the atmosphere seems to be preferentially absorbing that light instead. This observation led to the late astrobiologists Harold Morowitz and Carl Sagan to propose that energy-hungry photosynthetic organisms might be the culprit. Meanwhile, other researchers have never stopped searching for alternative abiotic explanations. Recent evidence suggests that the planet is still geologically active, and a model released earlier this year showed that Venus might have had an ocean for nearly 3 billion years, one that only disappeared a few 100 million years ago. Conceivably, life could have arisen on Venus when our sister world was much more Earth-like, only becoming airborne as the runaway greenhouse effect rendered the planet's surface uninhabitable. I've always thought it's as plausible to have life in the clouds of Venus as to find it in the subsurface of Mars, said Dr. David Grinspoon, an astrobiologist at the Planetary Science Institute, who is not involved with the study. Each is an environment that could be habitable but isn't guaranteed to be. Yet an almost equally good case could be made for Venus's clouds being inimical to life as we know it. Microbes have been found floating around in Earth's atmosphere, but none are known to exclusively spend their entire life cycle there. All of them had to land eventually, and Venus's surface seems too inhospitable a place to make for a good reservoir. The Venusian area under consideration is also 50 times more arid than Chile's Atacama Desert, the driest place on our planet. And although it's true that living things have found good ways to thrive in aqueous environments tinged with traces of sulfuric acid, conditions on Earth's evil twin essentially reverse that order. Its cloud layer is mainly sulfuric acid with just a bit of water. Venus remains an unexplored place. Despite it being literally the planet next door, there are many mysteries that still need to be solved, Wong says. In order to rule out all non-living explanations for the creation of phosphine, researchers will have to learn a great deal more about the planet itself, including its chemistry, geology, and atmospheric physics, he adds. Alrighty, let's go back to the net. Check-ins, please come now.
Kilo 5. Juliet, Delta Whiskey, Mobile, Cedar Hill.
This is Kilo Golf 5, Echo, India Uniform, David, St. Paul, Texas.
Okay, we got K5JDW John and KG5EIU David. All right, let's move on. Next up, Chaz, KF5JHA with What's Up. Go ahead, Chaz.
Good evening, everyone. This is Chaz, KF5JHA. Thank you, Brenda. My degree is in astrophysics, and I'm the astrophysics lab manager at Dallas College on the Brookhaven campus. We call this segment of Skynet What's Up. Tom, we're on slide 2. The moon was new on Thursday, September the 17th, just a couple of days ago. And if you went out tonight, you could have seen a thin crescent moon. Looked like it was kind of hazy outside because the moon looked like an orange-yellow color to me. So the current phase of the moon is a waxing crescent. The moon will be at its first quarter on September 23rd, and the moon will be full on October the 1st. Slide 3. Yesterday in the evening sky, as twilight faded on September the 18th, you could have looked for the thin crescent moon, even thinner crescent moon. And to the lower left of the moon, you could have spotted maybe the planet Mercury. And to the upper left of Mercury, you could have found the star Spica. Slide number 4. September 22nd is the autumnal equinox. The autumnal equinox occurs at 8:30 a.m. Central Daylight Time, and the sun will shine directly on the equator, and there'll be nearly equal amounts of day and night throughout the entire world. This is the first day of fall, or the autumnal equinox, for the northern hemisphere, but the first day of spring, the vernal equinox, for the southern hemisphere. And on this day, the sun rises east and sets directly west everywhere on the Earth. Well, where does the sun rise and set the rest of the year? And once again, Kelly, K5KTX, she'd appreciate this since she's a birder watching birds. Think about birds. Which direction do the birds fly in the winter? Well, they go south, and that's where the sun rises. It rises south of east and sets south of west. And in the summer, the birds fly north, and the sun rises and sets north of east and north of west during the summer. I'm sure the birds are following the sun and not the other way around. Slide number 5. Also on September 22nd in the evening sky, just as twilight is fading around 7:45 p.m., look in the southwestern sky for Mercury and Spica in conjunction. They'll be very close together. Mercury will be a little higher and slightly to the left of Spica. And my call sign is KF5JHA, and this is Skynet. Slide number 6. At 11:30 p.m. on September the 24th, look in the southwestern sky for the moon to be just below the planet Jupiter. The fainter Saturn will be just to the upper left of them. Saturn and Jupiter are getting closer and closer together, and they will be in conjunction on December the 20th and 21st in the evening sky. The last great conjunction of Jupiter and Saturn was on May 31st, 2000. But on December 20th and December 21st of this year, the two planets will be so close together they'll look like one object to the naked eye. And in telescopes, you'll be able to see both planets in the same field of view at the same time. And not too far from now, an early morning of October the 2nd, by looking east, you can find Venus and Regulus in conjunction. Regulus is the bright star in Leo, the lion. Okay, slide number 8. On October the 2nd, in the evening sky, you'll be able to find the moon and Mars in conjunction in the eastern sky. You'll be able to see them easily by 11:30 p.m. This is slide number 9. It was the end of the summer of 2003. It was toward the end of August, but I don't remember the exact date. But a group of over 30 task members had gathered on the Richland College campus with telescopes to have a public observing station to look at Mars. Mars was at its closest that it had been since September the 24th in the year 57,617 BC. Don't know if there was too many people looking at it then. The sky was clear, and the news media must have been doing a great job of getting the word out. There were no less than 25 people in line at each telescope for most of the few hours of the event. I wasn't in Dallas for the Halley's Comet craze, but this event must have been at least equal to the 1986 Halley's Comet event. Slide number 10. About every 26 months, both Mars and Earth are on the same side of the solar system. That means they are close to each other about every 26 months. NASA uses this to their advantage by often sending spacecraft to Mars about every 26 months when the two planets are close together. Slide number 11. Opposition is when the object is opposite the sun, which is 180 degrees apart in right ascension, in the sky as viewed from the Earth. If all the planet orbits were circular and all were in exactly the same plane as the Earth's orbital plane, then the moment of the planet in opposition to the sun in the sky would be the same as its closest approach. But since this is not the case, opposition and closest approach are usually a few days apart. October the 13th in 2020 is the opposition of Mars, while October the 6th, 2020 is the closest approach. Slide number 12. All the planets, including Mars and Earth, orbit the sun in elliptical orbits and are not precisely in the same orbital plane. Mars is closer to the sun during the perihelion and is further away from the sun at aphelion. The same is true for any planet, including the Earth. If Mars is near its perihelion, which is closest to the sun, and Earth is at its aphelion, which is furthest away from the sun, and they are on the same side of the solar system, then the planets can be really close. This happens about every 15 to 17 years. The very closest approach planet Mars and Earth can come is about 33.9 million miles, but this is just an ideal circumstance. Slide number 13. Back on August 28th in 2003, the distance between the Earth and Mars was only 34.65 million miles. On this last close approach of Mars and the Earth on July the 31st, 2018, just a couple of years ago, we were separated by 35.8 million miles. On this close approach on October the 6th, 2020, we will be able to be separated by 38.6 million miles. The next really good close approach will be in the year 2035. But it will be in the year 2287 on August the 28th for Mars to get closer than it was in the year 2003. So we're up to slide number 14. It doesn't look like we can have any public observing stations with this Earth-Mars close approach, so grab your own scope and head outside during the first half of October. Right now, if you go outside, you might be able to see Mars over there in the southeastern part of the sky. Okay, slide number 15. Let's talk about the upcoming meteor showers in October. There are 5 meteor showers worth talking about in October. 3 of them are in the first half of the month, which I'll cover right now. The other 2 we'll do at another time. The Camel-Parted meteor shower on October the 4th and 5th will have about half a dozen meteors per hour. The Draconid meteor shower peaks on the night of October 7th and 8th with between 3 to over 1,000 meteors per hour. They have that meteor shower sometimes has something called a meteor storm. We don't know the prediction of when the meteor storm will happen, but it could be this year. I'd go out and take a look. And the Southern Taurids peak on the night of October 9th and 10th with about half a dozen meteors per hour. I always suggest camping at a state park. Need to get that fixed. The Texas State Park System to watch meteors. For details about meteors and meteor showers, visit the American Meteor Society at amsmeteors.org or the International Meteor Organization at imo.net. I've already mentioned earlier in this net about the Texas Astronomical Society meeting on September 25th at 7:30 p.m. And once again, if you want to get more information about the Texas Astronomical Society of Dallas, go to texasastro.org for details. Now, do any of you out there in Radio Land have any questions or need a fill of any information? Or do you have just a general astronomy question? I don't know everything, but I may know the answer to your question. Come now with your call sign if you have a question. Okay. I want to welcome the students from Brookhaven College that are listening and watching Skynet tonight. Students, remember, you need to get your stargazing class credit for this. Then you need to fill out that form within the next 48 hours. Details are on your website. So, slide number 18. As the moon will wane at the last part of September, so do these words for this segment of Skynet. Stay safe, keep well, pray for our world, and until next week, keep looking up so you know what's up. And this is Chaz, KF5JHA, back to Brenda, our net control. Thank you.
Thank you, Chaz. Next segment is space exploration and space history, and that's going to be covered tonight. 5BB. Bill, go ahead.
Hi, this is N5BB, and tonight I'm going to talk about the solar cycle, and in particular, solar cycle 22. Excuse me, wrong number. Solar cycle 25, which is the one that we're now in. So let's start with some background on this. The first thing you might ask is, why do we care about the solar cycle? Well, we care about it because during the solar cycle, the sunspots vary up greatly, the number of sunspots. And the number of sunspots correlates with release of quite a bit of high-energy ultraviolet energy from the sun, as well as other kinds of events, coronal mass ejections and other things. And this differing activity for amateur radio operators affects, in particular, shortwave communication, because it affects the ionization of our ionosphere. So, when there's lots of sunspots, there is more ionization in the ionosphere, and that, in general, usually, for most frequencies, makes it much easier to talk to distant locations on HF radio with good signal strengths. It's a complicated thing, so I'm not going to get into the details of that. There's other things that happen, though, that aren't good. When the energy from the sun, the emissions from sunspots and other things, gets very large, it, besides ionizing the ionosphere, it also causes the upper atmosphere to expand because it heats it up. And what that does is it dramatically increases the drag on low-orbiting Earth satellites, especially ones whose perihelion is low. And the International Space Station. So it makes a huge difference. So if you have a large amount of solar activity, satellite orbits actually start decaying. In some cases, this has led to satellites that we lost much earlier than anticipated, because their orbits decreased to the point that they had to run away, slow down, and burned up in the Earth's atmosphere. Also, certain events associated with high solar activity make it more likely to get huge coronal mass ejections and other things, which can dramatically affect our power grid, can lead to huge amounts of current going into long-distance power lines and other problems. So anyway, space weather is very important. That's the deal. So, this is N5BB. Why do we call the current cycle solar cycle 25? Good question. Well, the first solar cycle was arbitrarily numbered as number 1, and it began in 1755. So you might say, how long is a solar cycle? This numbering scheme assumes the length of a solar cycle is roughly 11 years. However, what's really going on is it's a 22-year cycle. So we're in solar cycle 25, numbering on the 11-year cycles. But it's really 12 and a half cycles. Here's why. Every 11 years, if you look at sunspots, you see their number going up and down. And the current cycle started in December of 2019, when the sunspot level smooth number was very low. It's starting to slowly increase now, although you can't tell it this week, but it's starting to slowly increase, and the current cycle will probably peak in 2025. And after that, the sunspot number will slowly go down. So this is the 11-year cycle. Well, during the 11-year cycle, what happens besides the number of sunspots increasing? Well, if you go through the minimum, in other words, if you look at the sunspots in early 2019 and compare them with the ones now, the magnetic fields are swapped. So if you look at a sunspot with an instrument that shows you the magnetic fields, it's a dipole in that there's one side of it is magnetic north and the other side is magnetic south. And they're kind of lined up parallel to the equator of the sun. And if you look at the polarity, looking at the sun left to right, of these sunspot magnetic fields last year, it's completely flipped around opposite this year. So during the sunspot cycle, the magnetic polarity of these sunspots flips. And then it continues to be the same for 11 years. And then at the next minimum, it flips back to the earlier polarity. So that's one thing that happens. But there's another thing that happens. The whole dipole magnetic field of the sun, you might think of it having, like the Earth, the north and south magnetic poles. It's aligned roughly with the axis, the rotational axis. That magnetic field also flips every 11 years. So the complete cycle is 22 years, okay? The complete magnetic cycle is 22 years, composed of two 11-year cycles with the sunspot numbers going up and down. This is N5BB, kind of contributing to Skynet. So, again, we expect, the reason you're hearing about this now from me is that recently, like in the last week, there's been various science articles coming out talking about the consensus of solar scientists who have been arguing about this greatly. But they believe that the minimum was in December of 2019. They believe the maximum will be near somewhere around 2025. They also predict that the number of sunspots at that 2025 maximum will be similar to the sunspots maximum during the previous cycle, cycle 24. which is good news because some scientists have been very worried that the number of sunspots have been going down over the last few decades, and that we might be approaching a Maunder minimum, which occurred in 1645 to 1715, when the number of sunspots was essentially zero. But the latest indications are that that will not occur, and that we're getting ready to start slowly going up with the sunspot cycles getting stronger and stronger. By the way, from 1940 until 2000, the numbers of the sunspot peaks were stronger than in the previous many thousands of years. So, which is really good for shortwave communications. That's why we discovered it. One last thing, there is a new satellite which is being planned, and it should be launched in 2024. Its name, the current name, is the Space Weather Follow-On, which is a horrible name. Anyway, it's the first satellite observatory dedicated exclusively to operational space weather by NOAA. It will have instruments that sample the solar wind, provide images of the coronal mass ejections, and monitor other extreme activity from the sun in finer detail than before. This satellite is going to be located at the L1, the Earth-Sun L1 point. This is about 1 million miles toward the sun from the Earth. And because of the gravity of the Earth, the satellite at that point will have the same orbital period as the Earth, 1 Earth year. So it'll always be between the Earth and the sun, and it will be 1 million miles closer, which means it will see things before we see them. If it's things which are electromagnetic, it cannot alert us any sooner, because the speed of light is the speed of light for any frequency. However, if it senses solar wind, which is particles coming from the sun, they're traveling fast, but significantly slower than the speed of light. So it will be able to alert us of major coronal mass ejections and things which are releasing a large amounts of particles. And that will be very, very good to give us a warning of minutes to hours before major events hit us. That's all I have now. Thank you very much, Brenda. This is N5BB. Back to that control.
Thank you so much for taking that, Bill. Okay, do we have any more check-ins?
Question, K5 Whiskey Tango Foxtrot, Johnson Denver.
Okay, we doubled. Who had the question?
This is Russ, K5OSH. I'll wait.
Okay, who was the other one?
Well, I guess I got everything messed up. Let me see, do I have it?
Okay, Russ, you have a question, K5OSH?
Yes. We need to, we're talking about looking at the sun and seeing sunspots, but it's not a real good idea to look directly at the sun. So there ought to be some simple way that we could do something so we could look at it and see these sunspots. That's my question, K5OSE.
Would any of you astronomers like to address the question?
KF5JHA.
KF5JHA, go ahead.
Good evening, Russ. Yes, there are special filters that you can use in order to look at the sun. So you don't really look directly at the sun. I've got some filter material that only lets 1/100,000th of the light of the sun coming through. We have a special telescope at the college that only lets out a little bit of red light from what's being emitted by the hydrogen atom from the sun. It's called a hydrogen alpha filter, and we're only seeing a little bit of that. So we're not looking directly at the sun. We'd burn our eyeballs out. And so don't ever look directly at the sun unless you have proper filtering. There is a way of using a telescope, if you want to try to do it this way, of projecting the image of the sun on a piece of paper. But be careful, because if you have it too close to the telescope, it might catch on fire. But you can project the image of the sun on a piece of paper and then actually see the sunspots that way. So that's two different ways of doing it, either special filtering or just a projection. Did that answer your question, Russ?
Yes, it seems like when I was in grade school, we used to use exposed negatives or something like that to look at it. And then another way that we did it, as I recall, was with a mirror and focus the reflection out of the mirror onto a piece of cardboard. I don't remember the color of the cardboard, but naturally you can't look directly at it, but we had a way to reflect it onto another piece of paper or on a mirror or something like that. Am I remembering things wrong, K5OSH?
Yeah, the reflected light off of a mirror onto a distant, it doesn't need to be a piece of cardboard, it just could be a wall. That works for looking at solar eclipses. You really can't see the details of sunspots with that. And also, with the naked eye, unless the sunspots are really big, bigger than the Earth, which a lot of them can be, it needs to be many times bigger than the Earth, like 10 times bigger than the Earth, then you can see them. If you have those special solar eclipse glasses, you might be able to see them then directly. I would not recommend exposed black and, well, it was just, black and white film back at that time, because actually some of the harmful infrared and ultraviolet rays can get through that, and that could still damage your eyes, so I don't recommend that. The special solar eclipse glasses, if you want to look just up at the sun during an eclipse, those are pretty inexpensive. You get them for between $2 and $5, depending on how fancy they are. Okay, this is KF5JHA.
All right. Well, don't catch your breath yet, Chaz. You're up. This is Miss Carolyn's Constellation of the Week, KF5JHA. Go ahead.
Thank you, Brenda. And yes, this is KF5JHA. Miss Carolyn's Constellation of the Week is named in honor of Silent Key, Carolyn, KC5OZT. Carolyn contributed to Skynet each week, almost from its beginning in 2012 until May of 2019, with a detailed look at one particular constellation each week. Since there are about 52 easily visible constellations seen in Texas throughout the year, out of the 88 total constellations, Miss Carolyn covered the entire sky in just a year. In her honor, we have continued that tradition of a constellation per week. Miss Carolyn's Constellation of the Week this week is Cygnus, the Swan, or the Northern Cross. Cygnus is the constellation of the Swan, since it is not hard to use the stars of Cygnus to trace out the shape of a swan flying along the Milky Way. It's not surprising to learn that Cygnus has been visualized as a swan by several different cultures in the past. In one myth, Cygnus is a swan whose form Zeus adopted in order to seduce Queen Leda of Sparta. In another, Orpheus, the father of song, was transferred into a swan after he was murdered. Cygnus Cygnus is one of the three constellations that are involved in the well-known asterism of the Summer Triangle. Cygnus is the brightest star, Deneb, forming one of the three stars of the corners of the triangle. The other two stars are Vega in the constellation of Lyra and Altair in the constellation of Aquila. The brightest stars in Cygnus form a well-known other asterism called the Northern Cross. So, Tom, we're up to slide number 20. Deneb, Alpha Cygni, is the brightest star in Cygnus, the Swan. The name Deneb is derived from the Arabic word means tail, owing to its position as the tail of the swan. Deneb is also the head or the top of the Northern Cross, and as such has been referred to as the Star of the Cross, according to Burnham's Celestial Handbook. By the way, it's kind of interesting that there's a Northern Cross that actually stands upright in the northeastern sky right on Christmas Eve. Deneb is a blue-white supergiant star, one of the greatest supergiant stars known, shining brightly at magnitude 1.3 as seen from the Earth, despite its distance of 1,700 light years. Slide number 21, Albireo, is also known as Beta Cygni, is a beautiful third magnitude double star. Albireo is considered to be one of the most beautiful double stars in the sky due to the contrasting colors of its two members. The primary is yellow, and a fifth magnitude companion is blue or a blue-green. These two colors make an easily noticeable color contrast, and as such, Albireo is a great demonstration object for showing newcomers to astronomy that stars come in different colors, and they're not just all white. By the way, the colors have to do with temperatures of the stars. Another trait that makes Albireo a good introduction object is the fact that it's easily split into two different stars in any telescope. In fact, it can be split with binoculars, held at very steady conditions or mounted on a tripod, which is why it's a candidate for the Astronomical League Binocular Double Star Observing Club. Albireo is about 410 light years away, and since both stars share the same proper motion, it is believed to be a true physical pair. In spite of their separation of 4,400 astronomical units, which is about 400 billion miles, due to its wide separation, no actual orbital motion has been detected between the two stars in almost 2 centuries of observing and measurements. Slide number 22. Cygnus X1 was the first black hole to be scientifically identified by astronomers. It is part of a binary system in Cygnus, and with a black hole and a blue supergiant star known as HD 226868, orbiting around each other. So the black hole is a remnant of a past star. Of course, the black hole itself cannot be observed with backyard telescopes, but HD 226868 has a visual magnitude of 8.95, in other words, almost magnitude 9. So it's easily visible in virtually all amateur telescopes. It lies about half a degree from the fourth magnitude Eta Cygni. And this is KF5 JHA, and this is Skynet. Slide number 23, NGC 7000 is also known as the North American Nebula, located near Deneb. The North American Nebula can be easily seen with the naked eye as a bright spot in the Milky Way from a dark sky site, if you know exactly where to look. Using a nebula filter held in front of the eye makes this much easier. Binoculars or a low-power wide-field telescope are best viewing for NGC 7000. In fact, it is generally agreed that smaller, short-focused instruments of about a 3 or 4 inch size are best, and it can be seen in a 10-inch stop, but even at lowest power, you can't see it all at once. NGC 7000 is observable without a filter, but it's much easily seen with the appropriate nebula filter. NGC 7000 was discovered by William Herschel in 1786 and was first photographed by astronomer Max Wolf in 1890. Dr. Wolf is the one who named NGC 7000 the North American Nebula because of its shape. Looks like North America. Okay, slide number 24 is IC 5070. Most of the time when you see a IC designation, it means you can't see it, but in this case you can see it. It's better known as the Pelican Nebula. It's located right next to NGC 7000, the North American Nebula, but it's way out in the Atlantic Ocean, which is an appropriate place for pelicans. I like that joke. It and NG 7000 are believed to be parts of the same gas cloud. It's only intervening dark nebula that makes them look like two separate nebula. Just like the Great Orion Nebula, M42, and its nearby neighbor in M43 appear to be two separate nebula, but they're actually a single cloud split by an intervening dark cloud. These dark cloud nebulas are dust or gas that's not illuminated. Slide number 25. M29 is an open cluster of stars that does not stand out distinctly from the Milky Way background, but it might if it were not for the intervening dust clouds. There they are again. The particular area of the Milky Way where M29 is located is heavily obscured with dust, dimming the stars at M29 by at least 3 magnitudes. M29 would be a very striking object if it weren't for those intervening dust clouds. Slide number 26. M39 is an open cluster as well and is visible to the naked eye from many dark skies. Dave Hutchinson notes that while he was seeing it without optical aid. Stephen James O'Meara also notes that it is visible to the naked eye, appearing as a small fuzzy patch about 9 degrees east-northeast of the net. Being a naked eye object, M39 makes for a wonderful binocular object, but in a telescope, it requires a low power to see all of the cluster at once. Slide number 27, NGC 6826, is a blinking nebula, or the blinking planetary. So it's a planetary nebula. It looks exactly the way Dave Hutchinson describes it in this article in the Task Spectrum newsletter. The reason that the nebula appears to blink is because the central star overwhelms the eye. So if you look at it quickly, you just see the star. But if you let your eye look at the entire field of view through the eyepiece, you might notice the nebulosity out of the corner of your eye. Then look at the star again, and the nebulosity is gone. In other words, using averted vision on this object is the best way to see it. Keep switching between averted vision and direct vision, and you'll see the nebula blink. Just one more object to go through. Slide number 28, NGC 6960, 6974, 6992. In 1784, with an 18-inch telescope, Robert Burnham Jr. wrote in Burnham's Celestial Handbook that many observers have seen the brightest portion of the Veil Nebula in 7x50 binoculars. In 7x50, it is a faint but unmistakable object. Stephen James O'Meara confirms this, and you can see much more of it with a 10-inch Dob, but without a filter, it resembles faint cirrus clouds that are fairly featureless. Therefore, an O3 filter is a must-have for a tool for viewing this veil. And with an O3 filter, what was the almost featureless becomes a full of structure with the same telescope. The filamentary nature of the veil becomes readily apparent with this O3 filter. It looks just like the photograph. The western veil, NGC 6960, is easily found because it nearly touches the foreground star 52 Cygni, which is about a magnitude 4.2 and is a naked eye star. It's easily found in a finder scope. And this is KF5JHA, and this is Skynet. There are more Astronomical League observing program objects in the constellation of Cygnus and Swan, the Northern Cross. I have just given you a sampling of a few of those objects, and the Astronomical League has over 60 different observing programs, most of which have about 100 objects. If you observe just 10 different objects from that observing program and each month, then you can earn an observing certificate and a pin in about a year. And slide number 30, that is Miss Carolyn's Constellation of the Week, Cygnus the Swan, or also known as the Northern Cross. I want to thank my friends Dave Hutchinson and Dennis Harwell for their research and words that I keep using in these deep sky objects that I've talked about tonight. I've also used the website, constellation-guide.com, for information as well. Next week, we'll take a look at two small constellations. Yes, it's a two-for night next week. Delphinus, the dolphin, and Equus, the horse. And this is KF5, JHA, back to net control. Thank you, Brenda.
Thank you, Chaz. All right. Any more check-ins now?
November 0 Zulu Golf Oscar.
W5GUS, recheck.
Okay, I think we got November 0 Golf Oscar, and your name, please?
Yeah, November 0 Zulu Golf Oscar. Name is Zach. Zulu Alpha Charlie Hotel.
All right, great. And W5GUS, recheck. Go ahead.
Thanks, Brenda. W5GUS here. Quick question about the previous subject Bill was talking about, the sunspot. Maybe Chaz would know. I'm curious if the mechanism that reverses the sunspot polarity every 11 years, if that has been identified, or is there a theory on how that happens? W5GUS.
It's a great question. Anybody want to take it?
For KF5, JHA.
And I might have other comments after Chaz and 5BB.
KF5JHA, go ahead.
Thank you. Actually, we don't know the mechanism for why it happens. But you know what? It actually happens on the Earth, too. The Earth reverses this polarity every so many thousands of years. And actually, we're overdue for a flip of the Earth's magnetic field. So, hey, what's going to happen with that? We've talked about this on this net before, but we'll leave that for another time. We don't know the mechanism yet. I guess, can I hand this over to Bill? Go ahead.
This is N5BB. I agree with everything Chaz said, except there are a number of theories about the sun's magnetic field, just like there are about the Earth's. The number of ones about the sun is probably even larger than the number of ones describing the Earth. But there are, some of it, Gus, involves, think of some magnetic fields that are kind of getting twisted up, because for one thing, if you look at the sun, the rotation rate at the equator is quite a bit different than the rotation rate near the pole. So the sun is not one big solid rotating body. It's some things rotating at different rates, at different latitudes, and probably different depths. And so I think they believe that there's a magnetic field that's kind of getting twisted up and then coming up, and the lines are appearing above the surface, causing the sunspots we see. But it's an incredibly complex thing, and there's nothing that duplicates. Nobody has anything that duplicates everything that we see. This 22-year cycle, plus the long-term and short-term setup. So again, as Chaz said, we don't know. In Habibi.
All right, well, we got a lot to look forward to learning about all this. Space launches for this week. Tom, KE5ICX. Take us into space.
Well, it may be better than on the Titanic, too. Well, let's see here. All my information that makes me really smart or makes me appear smart, well, not at all. Space Launches comes from spacelaunches.com and spaceflightnow.com launch schedule. You can go there and find all this information. By the way, all these launches are now televised, so if you want to watch any of them, there can be as many as 2 or 3 a day. Just look them up online with spaceflightnow.com. Is probably the best site. Here we go. Falcon 9, Starlink 12. This is to be determined, but it's coming up. Launch Complex 39A at Kennedy Space Center in Florida. Falcon 9 rocket will launch the 13th batch of approximately 60 satellites for SpaceX Starlink broadband network, a mission designated Starlink 12. September 26th, Delta IV Heavy and Roll 44 will launch from Launch Complex 37B at Cape Canaveral. The United Launch Alliance Delta IV Heavy rocket will launch a classified spy satellite cargo for the U.S. National Reconnaissance Office, the largest of the Delta IV family. The Heavy version features 3 Common Core boosters mounted together to form a triple body rocket. We also have, from the very big to the very small, we have an Electron STP-27RM to be launched at no date yet at Launch Complex 2 at the Mid-Atlantic Regional Spaceport in Wallops Island, Virginia. The Rocket Lab Electron rocket will launch on its first mission from the new launch pad at the Mid-Atlantic Regional Spaceport at Wallops Island. On September 28th, we have a Soyuz Gonet-M. The Soyuz, which is really an R-7 rocket, will launch from the Cosmodrome in Russia. This Soyuz rocket will launch 3 Gonet-M communication satellites and a cluster of international rideshare payloads. The rocket will fly on a Soyuz 2-1B configuration with the frigate upper stage. Overnight on September 29th and 30th, an Antares NG-14, which will launch from Wallops Island, Virginia. Again, this one is Pad 0A. Northrop Grumman Antares rocket will launch the 15th Cygnus cargo freighter on the 14th operational cargo delivery flight to the International Space Station. The flight, known as the NG-14, the rocket will fly the Antares 230 configuration with 2 RD-181 first stage engines and a Castor 30XL second stage. Powerful stuff. And then finally, another Falcon 9 overnight, September 30th to October 4th will be October 1st will be the GPS SB-04. This will launch from Launch Complex 40 at Cape Canaveral Air Force Station. This will be the third generation navigation satellite for the GPS system, or Global Positioning System. The satellite is built by Lockheed Martin. And that's it for me for this week. Back to you, Miss Brenda, KE5I6.
Okay, we're essentially out of time, so I'm going to skip my recent astronomical discoveries segment. Tom, do you want to do visible satellite passages report?
Normal state.
Well, we're almost done, but if you go to, where the heck is it, heavens-above.com, plug in your longitude and latitude, you'll get all of this information. I'd highly recommend it, especially now that we've got the repeater or crossband repeater up on the International Space Station. You can see it and also make contacts through it. That is heavens-above.com. Back to net control. This is KE5ICX.
Okay, thank you. Any more check-ins, please? Right then, we're going to close it out. Tonight we had 23 hams participating on the air.
Completely
Thanks to all who
and all my
checked in this
circuits are
evening.
functioning
We
perfectly.
hope you'll join us here next week and every Saturday night at 9 p.m. to discuss astronomy, space, and space exploration. On this net, the sky is never the limit. We're always looking for net control stations for this and all other DARC nets. If you'd like to try your hand at this, contact any of the net controls by sending an email to nets@w5fc.org. You can follow topics and discussion about this net and astronomy in general on Facebook and Twitter, as well as our audio and video streams, video archives, and other useful resources by going to w5fc.org at the conclusion of this net. Until next Saturday night, this is WB50ZL, Brenda, and I'll be closing the net at 10:30 p.m. local time and returning the repeater to normal amateur use. Send it to everybody and enjoy the evening discovering the universe. And we'll meet back here in 5 minutes for tonight's Afterglow Movie Net.
Thanks, Chaz and Bill, for their answers to that solar question. W5GUS.
In a few minutes, you'll have an email with me with more details, Gus. There is a paper that was just published in July of this year in 5BB.
Ah, wonderful. I'm sure it's a complex problem. Both Earth and Sun have molten moving centers, so that could be something in common, and it seems like that would be a good possibility that has something to do with it. Anyway, thanks Bill, thanks Chaz again. W5GUS. Can't wait to read that, Bill. Thanks.
I don't know if they had actually had some Wi-Fi calling on the ship, but can't hardly see her being able to use the cell phone sitting out there in the middle of the Atlantic coast and talking to her father, although it did look like a couple of times that they did occasionally have sat phones. But last time he talked to her in the elevator, I don't know what he was using for a telephone at that time, because it looked like he was just talking into his headset microphone, unless they had him patched through the Coast Guard station somehow, which wasn't apparent. And don't know how they managed to get out of the capsized ship, because get out, they would have had to swim down and then back up, swim down around, and get back up. That would be confusing and primarily Marcus, and just get some glasses if the guy had come back at the very end. That would really have kept the
and there's a difference in the speed of the waves near the surface versus lower in the water. And because of that, near a coast where if the coastline is coming up slowly, in other words, if the depth of the water is slowly changing near the coast, the wave will have different speeds depending on how deep it is near that. And what that leads to is the water goes out, and then the big tsunami wave comes in. It has to do with this differential on the velocity. But this thing